All right, now that you know about the tangent ratio, there's two more trigonometric ratios that you need to know, and they're called sine and cosine. Basically, very similar to the tangent ratio, we still always have a right triangle, right? This time, our sine of theta is going to be our opposite over the hypotenuse. Similarly, the cosine of theta is going to represent our adjacent side over the hypotenuse. Okay, so these are the sides that are important. All right, so let's try this one. Find sine S, sine R, cosine S, and cosine R. Write each answer as a fraction and as a decimal rounded to 4 places. So let's start off with the sine of S and the sine of R. Okay, so let's set this up. The sine of S is going to equal our opposite over our hypotenuse. So let's find out where these values are. So S is located right over here. So what is the side that is opposite of S? Opposite is going to be right across from it. So 63 over our hypotenuse of 65. So if I were to, I don't think we could simplify this. So let's just approximate this. So the sine of S is going to approximate to, let's go ahead and put this into our calculator. Oopsies. Here we go. So 63 over 65 approximates to 4 places, 0.9692. Since it's 923, we're going to round down anyway. So that is our sine of S as a fraction and as a decimal. All right, let's do the same thing for the sine of R. So sine of R is going to equal, again, the opposite over the hypotenuse. That's the ratio. So sine of R, where is R located? R is located right here. So we're looking at this angle. So the sine of this angle R is going to equal the side that's opposite of it. So what's opposite of R? 16 over the hypotenuse of 65. So that is it as a fraction. And then let's go ahead and find the sine of R as 4 decimal places. So the sine of R is just going to be 16 over 65. So it's going to approximate to 0.24615. So since it's 615, the 5 or higher. So we're going to round up to 2462. So that is the sine of R as a fraction and as a decimal. All right, now let's try finding the cosine of S and the cosine of R. So the cosine of S is going to equal the adjacent over the hypotenuse. So the adjacent side over the hypotenuse. So cosine of S, so back to S. So what is the side that is adjacent or next to S? It is 16. So 16 over the hypotenuse of 65. We cannot simplify 16 over 65, so we'll leave it as is. So the cosine of S is going to approximate to, yet again, we already found out what 16 over 65 is. So 16 over 65 approximates to 0.2462. And then lastly, what is the sine of S going to be? All right, we already found the sine of S. I lied. The cosine of R. So cosine of R right over here. Cosine of R is the adjacent over the hypotenuse. So cosine of R, the adjacent side is 63 over the hypotenuse of 65. So that is it as a fraction. And then as a decimal, it looks like we already found the decimal of 63 over 65 right over here, which is going to approximate to, yet again, 0.9692. So what do we notice here? We notice that the cosine Oh my gosh, I can't even make a box. I'm not gonna make a box for this one. Our sine of S is the same value as our cosine of R, and then our sine of R is the same value as our cosine of S. So that's like a pretty neat thing to recognize here, okay? All right, that's it. Bye.